A very good afternoon, ladies and gentlemen. Meshmix Media, in association with IMS Foundation and Laghu Udyog Bharati, Karnataka, is proud to present the fourth session of its exclusive knowledge series spotlighting India's aerospace and defense sector. Today's topic of discussion is additive manufacturing and advanced materials in aerospace. And I have got a distinguished line of panelists: Dr. Calvin Samuel, Facility Manager, Polymer Additive Manufacturing Facility, Design Center of Excellence, DCOE, Indian Institute of Science, IISc. Dr. Vishwas Puttige, CEO and Director, AMS Solutions. We have with us Mr. Gaurav Relhan, Chief Strategy Officer and Head Aerospace Strategy Consulting, Aerodef Nexus. Before we start, for me, when I see additive manufacturing, the first experience for me was during Nepal earthquake, where additive manufacturing people have taken small of their machines where they have printed parts where they can give immediate relief for the earthquake. Then the second big was during pandemic, where all additive manufacturing companies, including Dr. Vishwas Puttige, where they have come up with design, they have given free design printing, so that mask and other things can be made available for a very bigger audience. And then aerospace, uh, since today's topic is aerospace, so we want to start with each one of each panelist, where they can talk about themselves, what they do, what their organization is. Let's start with Dr. Vishwas.
Sure. Thank you so much, Mr. Dinesh and team, for this opportunity. My name is Vishwas Puttige. I'm a part of Amace Solutions. So Amace Solutions is a part of the ACE Micromatic Group. ACE Micromatic has been in existence for 45 plus years, making CNC machines with more than 100,000 CNC machines installed all around the world. We are one of the largest CNC machine tool groups in the world and the largest in the country in India. Um, we've been doing CNCs and subtractive manufacturing for a long time. So additive came as a technological disruption for us about 8 years ago. Then we decided to switch from. Did I wait? I think there's some noise. All right. Okay. So additive came very natural to us as a technological disruption. We diversified into additive largely to ensure that we retain our customers. And as the technology upgraded with our customers, we wanted to ensure that we have solutions available for anything that they might be needing. So this company, Amaze Solutions, is a subsidiary of the large company. And here our main focus is to be able to make machines and sell them to customers. So we've been building machines and selling them to both industry, private industry, and government organizations. Today, multiple of our machines have made ways into the ISROs, the DRDOs. Then we have machines in multiple education institutions and private industries who've been using our machines to produce aerospace, defense, space tech parts. Then we have medical industry, we have mold making industry, automotive industries, and many others where our machines are being used extensively for end use applications. So like this, we've diversified into this technology. And as a part of our machines qualification to our customers, we've printed multiple parts as a trial, and also we provide services in our effort to justify the technology. So we've printed more than I think close to 1 million parts and supplied them all around. And today many of them have even made ways all the way to the space. We have parts sitting on the moon. We've worked on the Chandrayaan project. We've worked on many other government projects, including the Gaganyaan, which is right now going on as we speak. And then, of course, we have projects that we have done for many private sector companies. We have connected to more than 25 private space tech companies today in India for whom we have made parts, and then they're all being deployed for various applications. So that's our current work that we've been doing with the aviation and space industry in India.
Thanks, Dr. Vishwas. Gaurav, more about you, your company, what it does.
Yeah, so a bit about myself. So I'm a strategy and management professional with over 15 years of global experience, spanning finance, technology, aerospace, and international infrastructure development sectors. And over the course of my career, I have successfully led, various multi-billion-dollar strategic transformational initiatives at organizations such as JP Morgan Chase Bank, Meta, the World Bank Group, International Finance Corporation, FINRA, which is a financial industry regulatory authority. And across all of these organizations, as a strategy leader, I have driven transformation by driving and leveraging data-driven insights, market analysis, and cross-functional leadership. Currently, I'm the Chief Strategy Officer at Aerodef Nexus, which is a rapidly growing aerospace company based out of Bengaluru. And here I also lead the management consulting vertical. So a bit about Aerospace Nexus. So this company was launched in March this year, and we aspire to be the leader in India across the aerospace and defense sector, spanning multiple verticals. So we aspire to be the leader when it comes to manufacturing in the aerospace sector, provide management consulting services, strategic advisory support services. We strive to be the leader in providing high quality training content and modules to aspiring students who want to excel in this sector. We provide syndication support to firms looking to invest and grow and expand in this sector, and so forth. So that being said, thank you very much, Mr. Mishra, for inviting me today here as a panelist. And I look forward to contributing to the discussion during this webinar. So thanks again.
Thanks, Gaurav. And you are a team of ninjas. You have got a very good, I can say a LinkedIn marketing team. I can see you and Hardik going everywhere, meeting all the aerospace people. And best wishes from my side for, um, you know, for Aerodef Nexus Group. Dr. Kelvin, more about you. What you do?
Uh, yes, sir. So I am Dr. Calvin Samuel. I'm working in IISc as a facility manager, particularly for a Polymer 3D printing facility. So basically, what I'm doing here is I'm here to ensure the smooth functioning of advanced manufacturing facility, that including managing the 3D printers, coordinating with the vendors, and ensuring maintenance of high value equipments, and supporting the training program for engineering students. And my works basically focuses on optimizing the resource, ensuring safety compliances, enabling efficiency workflows to support both academic research and industry projects. So right now I'm in a DCOE, which is Design Center of Excellence project. So it is a government Karnataka project. So the aim of the project is to train the engineering students in and around the Karnataka in order to develop their skills and get them placed in a company. So that's all. This is my brief introduction about myself.
Thanks,
Thank you,
thanks,
Dr. Dinesh Mishra.
thanks, Dr. Kelvin. Now we can go deep in the subject. To start with, we wanted to understand what is additive manufacturing, what are the different types, and how it's varying from conventional, manufacturing method. So we want to start with you, Dr. Vishwas. Can you let our audience know more about the process and all? You are mute. No.
As the name suggests, additive manufacturing is something where we add material to create a part. So conventionally, the techniques that we know are either the bulk material is created using through casting, forging, or extrusions, welding, maybe a solid block through which we machine it and then get the final part. So there are multiple methods of making parts. That is for metal. Then you have plastics in different ways that we do parts, are either through injection molding or blow molding and many others. So those are all something that's lasted for more than 35, 40 years now, where parts are being produced for various applications using those conventional methods. And they're very largely mechanized, automated, and they've been running continuously and largely suited for high volume production applications, which is why we have had a wonderful growth in manufacturing in these past decade or two, where we have seen mass production and economies of scale kicking in and adding significant values into cost per part and the whole manufacturing ecosystem. Now, what additive does is basically it changes the whole process where we add just enough material wherever it's necessary to create the final form. Now, a part goes through multiple processes in the conventional process to get the final shape. From the design to the final part, it goes through multiple processes in between processes. Whereas with additive, the advantage is you can take from the design directly to the finished shape in a very short time. So that's the biggest advantage that we have. And we can do that in a very short time, considering the entire investment of time and money that would be required to for these multiple processes. So for this is a technology which is specifically suited for your design, new developments, prototyping, and small batch production, where your volumes are low, where you have other challenges, complexities in design, shape, and other challenges in manufacturing. Those are some of the key areas that additive is adding significant value to the end user. So today it's come of age. It's become earlier what started off as a prototyping technology today has become mainstream for many industries in manufacturing, be it healthcare, aviation space, or even defense applications. Some of the other small batch production applications, people have started using additive because the equipment costs have been coming down, the raw material costs have been coming down, the productivity levels have been going up, and the versatility and the variety of materials that are there for manufacturing, they're all been increasing. So which is giving a lot of scope for producing parts, final end use parts using 3D printing or additive manufacturing. So this is in a nutshell. Happy to add more as we progress through the whole discussion.
Thanks, Dr. Vishwas. Dr. Kelvin? So Gaurav, you can answer. The same only, what is additive, and it's how it is, relevant in aerospace sector, and why is it beneficial?
Right, right. So Dr. Vishwas gave a very nuanced answer, very detailed. So I think I'll take more of a bird's eye view approach towards answering that question. And first of all, thank you so much for asking that question to begin this session. So basically, for listeners who are new to this field, additive manufacturing or 3D printing in layman terminology, as Dr. Vishwas explained, it is a kind of like a process of building three-dimensional objects layer by layer from a digital design. And in context of aerospace, advanced manufacturing enables the creation of highly complex, customized, and high-performance parts with a very quick turnaround time and cost efficiency, which in the aircraft and spacecraft manufacturing sector is very crucial. So basically, through this technology, one can imagine the extent to which, one can imagine the extent to which, this technology can revolutionize design possibilities in the aerospace and design sector and boost manufacturing efficiency in this industry, and thereupon drive economic and industrial growth. So this is why, this technology can be highly beneficial in the aerospace and defense sector.
Thanks, Gaurav. Dr. Kelvin?
Yes, sir. Actually, okay. So we need to understand what is manufacturing first. Then I will give an introduction about subtractive and additive manufacturing. So basically, manufacturing is the process of transforming the raw material into a useful product. So that is called manufacturing. So in a broader term, the manufacturing can be classified into two types. One is subtractive, the other one is additive. Subtractive manufacturing we can relate with the sculpting process. So it's more like removing unwanted material with the help of tools till the desired shape is attained. So that is called subtractive manufacturing. Whereas additive manufacturing is a layer by layer adding material uh, till the desired shape is attained. So that is called additive manufacturing or 3D printing. So basically, as per ASTM standard, there is a standard called ASTM F2792. There are totally 7 main classifications of additive manufacturing. So under each main classification, there are a lot of sub-classification. For example, the 7 main categories are binder jetting, material extrusion, direct energy deposition, powder bed fusion, and sheet lamination, material jetting, and wet polymerization. These are the primary 7 main categories of additive manufacturing. So, what is the primary principle behind all this additive manufacturing method is to convert the raw material into a thin solid layer. So, once the thin solid layer is created, subsequent solid layers will be added one above other till the desired form is attained. So, that is the primary concept or primary principle behind all these additive manufacturing methods. So basically, in all this 7 additive manufacturing method has a 3 common stages. That is pre-processing stage, printing, and post-processing stage. The pre-processing stage begins with creating a CAD model. So once the CAD model is created, the CAD model should be converted into 3D printer acceptable file format, that is called STL file format. So after STL conversion, it has to import it into a slicer software which generate G code for each layer. So based on the G code, the printer will start creating or start transforming the raw material into a thin solid layers. So after printing, we need to do post processing. This post processing will differ from technology to technology. In plastic, it is very simple, just by removing the part from the build platform. Whereas in material, we have to rely on subtractive manufacturing method just to remove the part from the build platform. That's all from my end.
Thanks, Dr.
Then,
Calvin, for a detailed, answer. So now let's move. How to choose additive manufacturing over conventional method? Uh, Dr. Vishwas, when we should choose additive in place of, conventional manufacturing? You are mute, doctor.
It's actually a good question. Invariably, this is what we get asked most of the time. See, one thing is very clear: additive is not suited for an industry where people have been successful in making it using the conventional method. So it's not a method where we can go and say, look, you're making this for 5,000 rupees, I can make it for 4.5 or maybe a rupee lesser. So this will not fit into that kind of a market yet. So the only way that we can do it is where we can find value. Unless we can demonstrate value to an end customer, value is different for each person, right? So that is what we have to find out for the end customer. So largely the value is got to do with time. Say for example, an automotive industry, if they have a launch for a specific, maybe a festival launch or an auto expo launch of a product, now for them time is of immense value, because they can't postpone an event, they can't postpone a festival. So they have to have a product launched at a specific date, on a specific date. So to make that happen, sometimes we've had hurdles in our development process, which has led to some additional time taken away in finalizing the design. Now, to get that proto done, a conventional method of either doing a die casting method may run into many weeks, if not months. So what 3D printing does is to minimize that into a few days from months. So that's one huge value. Now, when it comes to aerospace, the biggest value is weight. Now, lighter the aircraft, more fuel we can carry, longer we can fly. Today, if you remember, I mean, there were no flights which could fly 18, 20, 22 hours direct from Bangalore to Los Angeles, I mean, or California or any other long haul flights. We had to take a pit stop. So now I'm not telling additive has helped, but light-weighted aircrafts have definitely come into play, and they have been adding immense value in carrying more fuel and flying longer distances. Same thing when it comes to spacecraft. The value is multifolded. I mean, you're able to carry more payloads. Now, a payload is what makes the difference. You can carry so many more satellites for a launcher when you launch it. So, like this, value is of immense importance in every technology. Now, rejection is another thing. There are manufacturing processes where rejections are as high as 30-35%. Now, when something like that is being dealt with, 3D printing can come in and add significant value there by bringing it down to less than 5%. So you maybe blowhole reduction in an aluminum die casting. So it's all about finding the right value. Where is it making sense to do the 3D printing route versus the conventional route? So some of the low hanging fruits are definitely where people have been having such problems, such challenges. Changing the whole methodology of manufacturing and exploring this as one of the potential one could be of immense value to the end customer. So it's all about finding what makes business sense, what makes technological improvement, what can be those specific additive advantages that can be leveraged on, is what we normally discuss with our customers. In some cases, we even identify those for our customers and say that how this can come in and help them solve those challenges.
Thanks, Dr. Vishwas. Dr. Kelvin?
Yes, sir. Okay, so in my perspective, we can choose additive manufacturing based on the advantages of additive manufacturing. So one of the main advantages of additive manufacturing is complexity, which is complex parts can be easily manufactured by the 3D printing technology or additive manufacturing. Let's say, for example, if the part is having very complex structure or complex shape, so we can go with the additive manufacturing technology rather than conventional manufacturing technology. So this is the complexity advantages of additive manufacturing. Next, the advantage is volume advantage. For example, if the number of parts which is going to be manufactured is less than 1,000, or we can say it as a batch production, we can go for additive manufacturing rather than conventional manufacturing method. In case if you are looking for mass production, 1 lakh parts or 2 lakh parts, it's better to go with conventional way of manufacturing. That's also.
Thanks, Dr. Calvin. Gaurav?
Yes, I feel that both, Dr. Vishwas and Dr. Kelvin, they are experts in this field. They are, PhD, so that's why, they have very detailed and nuanced descriptions. So, I really applaud them for their knowledge and the experience in this sector. From a strategy point of view, in order to just drive home the point as to when to choose additive manufacturing versus conventional manufacturing, from a strategy perspective to the audience here, I would like to say that, it'll be good to, to decide on this, like, there's just follow the rule of thumb here that, if you're looking at low volume production involving high complexity and customization, then choose additive manufacturing. And if you're looking for high volume production involving simple geometries, less complexity and less customization, then proceed with conventional manufacturing. This being said, it might be important to bear in mind when not to choose additive manufacturing. So, so again, as I mentioned, if you're going for high volume production of products involving simple geometries, then it's better not to choose additive manufacturing. If you're looking for producing products that involve materials that additive manufacturing cannot yet process reliably or economically, then definitely go for conventional manufacturing. And if you're looking for products involving tight tolerances and surface finishes that would require heavy post-processing, then it's best to avoid choosing additive manufacturing. So yeah, those are some insights from my side to answer this question.
Thanks. Dr. Vishwas, you told about weight reduction on the aircraft, and I know materials and all play a very important role. So, what are the techniques we can, keeping additive manufacturing into mind? What sort of techniques or what sort of things we can do to, reduce the weight of the aircraft using whatever we can do, wherever you see fit?
Right. So today, multiple materials are available for conventional I mean, the conventional manufacturing has few thousands, if not more, from material options. Whereas additive, if you ask us, one of the biggest areas of research and development that's happening, the fastest research and development that's happening is in the area of qualifying newer materials for 3D printing and for specific applications. So today, in that process, there are multiple non-metallics and metallic materials which have been qualified and are being qualified for different applications. Since the topic here today is largely aerospace related, I'll stick to more aerospace related ones. Today, globally, the biggest advantage that people have been leveraging from additive is either having stronger alloys or lighter alloys. So today, titanium is the poster child of additive manufacturing for aerospace. We have titanium, we have Inconel, largely Inconel 718, which is mostly suited for engine-related applications. Then we have aluminum for all structural-related applications, which is an aluminum alloy. So when I say materials, they're all aluminum. I mean, they're all alloys today. They are very popular in the manufacturing, I mean, using 3D printing route because of their specific applications, either strength one or high temperature withstanding capability or light weight as a unique feature. And then we also have newer materials like copper alloys, which have been coming up lately for manufacturing, which are also gaining a lot of popularity in especially engine-related applications. And then we also have the non-metallics, which are quite popular, which have been there for a while now, and also newer ones, especially your FRPs, your fiber reinforced polymers are being 3D printed today, either carbon reinforced or glass reinforced materials which are being 3D printed. You have much stronger materials which are even replacing aluminum, which are replacing metals today for specific applications, because again, for this specific strength versus weight ratio, and they've been able to qualify for multiple applications, and they've been coming into mainstream aerospace and space applications today. So that's in general from materials availability, materials suitability. Other than this, there are of course your conventional materials like stainless steels, which are there, which are for specific applications, but again, smaller volumes in terms of the aviation, space, and defense applications right now.
Thanks, Dr. Vishwas. Dr. Kelvin?
Yes, sir. So uh, basically, aircraft needs lightweight material. So why? Because it improves the fuel efficiency, the first one. The second one is, as a result, it extends the flight range and lowers the emission, as um, Gautam sir said. Okay, so basically there are three techniques we can able to reduce the weight of the aircraft. One is by choosing the lightweight material. The second one is choosing the additive manufacturing method, and the third one is design optimization method. So I will cover one by one. So we have to select a lightweight material, which means the material which have high strength to weight ratio. So first we have to select the material, and the second thing is we have to choose a material which is compatible for additive manufacturing, because not all materials are compatible for additive manufacturing process. So we have to choose a lightweight material as well as the material which is suitable for additive manufacturing. So once we choose a additive manufacturing supported material, we can get the benefits of additive manufacturing. The main benefit of additive manufacturing is complexity advantage, as I said before. So we have to create a complex part. How to create a complex part? So a design engineer has to combine multiple parts into a single complex part, and additive manufacturing can easily print the single complex part. As a result, we can eliminate unwanted fasteners, unwanted joining techniques to join multiple parts. So we can simplify the entire production line. It can save the time. Also, it can reduce the weight of an aircraft. And then once we adopt the additive manufacturing method, it opens a gate for design optimization technique. So design optimization is a simulation analysis. Basically, it's like topology optimization. So this topology optimization, what it will do, it identify the necessary material within the part and unnecessary material within the part. And by removing unnecessary material within the part, we can able to reduce the weight of a part by 20 to 30%. So the first step is we have to choose a material which is suitable for additive manufacturing. And once we adopt the additive manufacturing, we can potentially use the shape optimization technique. So that's all from me, Dinesh.
Thanks, Dr. Kelvin, for the detailed uh, response. Gaurav, tell me how much manufacturing in aerospace involves additive manufacturing, and what are the future trend you see because you are consulting a lot of companies.
Yeah. So based on our research at Aerodef Nexus, the global aerospace parts manufacturing market, this was valued at about $966 billion in 2024. And this is expected to grow to almost $1.5 billion by 2033, which implies a cumulative aggregate growth rate, or CAGR, of almost 5%. Now, in context of the aerospace sector additive manufacturing market, this specialized market is experiencing even faster growth. And from our analysis at Aerodef Nexus, this market is currently valued at approximately $8.3 billion. And, the value of this market is projected to reach at least $36 billion by 2032, which implies an impressive CAGR of almost 20%. So basically, this means that although the current share of additive manufacturing in this domain is nascent at only 0.9%, this is projected to reach 3.7% within the next 7 to 8 years. So basically increasing by almost 400%. And these figures, they highlight the increasing integration and importance of additive manufacturing within this sector of aerospace and defense. I would also like to add that although North America currently leads the global aerospace manufacturing market. The Asia Pacific region, including India, is identified as the fastest growing market for aerospace additive manufacturing, driven by increasing air travel demand and defense spending. So yeah, I mean, this is how I will address your question in that context.
Thanks, Gaurav. Dr. Viswas, the way I understand, first is the software which plays in designing, then comes, you can correct me, then comes the material, then comes the machine, and then the post processing. If a SME or MSME or some companies come from aerospace which may be making some components, since you are consulting, you are catering to the industry. What sort of what do you call? How do you work with this clients? End to end. If somebody comes to AMS Solutions with a problem or with a part or something, keeping all this angle, he wanted to come into Additive, but he maybe it's a startup. He doesn't. When it comes to design, choosing material and then the machine, because that also plays a major role. How do you consult a client, and what is your approach, when you meet this sort of clients, and what sort of solution you offer to them?
Good question. So there are two ways of approaching this kind of a situation. One is a user who already knows what they want to produce. They have certain families of components in mind. They have, I mean, if it's a startup, they already have an end user whom they've been approached by, and they know what components that the end user wants them to produce, or they have approached at least a dozen of customers for whom they'd like to make certain types of components. So that is one type of customer who has clarity in the business case or a use case. Second one, who has maybe an intention to produce, an intention to get into additive, but still has no idea as to whom they'll produce components for. So both types of customers come to us. So in both cases, we have to first make sure that there's a business case, there's a use case. People might have money today, God's grace, the funding is available. People with few PowerPoint slides are able to get a few crores of rupees comfortably. So there's no issue with that. But the challenge is, how do we keep the machine engaged? How do we make sure that the business rolls, the opportunity keeps coming, and the machine keeps producing? That's where that is what is our best interest. So we make sure that the customer understands that this is again, I'll come back to my term, value. They're able to produce these components better, stronger, lighter, faster. Whatever is that value that they're trying to derive from the whole process, that is what we quantify. And it has to be a metric. It has to be a number that is able to tangibly associate with the investment that they're doing on the whole ecosystem. So once that is clear, then we are into the process. We are in discussion. That's where the whole ball starts rolling. Then looking at their appetite of investment, what they look at doing, we end up providing them sufficient inputs in terms of going from all the way from design optimization, simulations, analysis, and whatever is required to make the part better. From there, all the way to making it suitable for printing, and just the infrastructure required for printing, which would be machine and all the accessories around it to get the whole ecosystem going. And then the next part would be the finishing part of it in terms of machining or other treatment, surface treatment, heat treatment, whatever that would come to make sure the part qualifies to meet the end use requirement. So now a lot of these can be outsourced too, while telling at this stage, I'd like to retain only the printing part, while other activities, I'd like to work with external consultants or work with others, supplier partners who could help us do that. So again, based on their investment appetite and their risk appetite as to what they intend to do as a startup, we end up consulting, we end up exploring, giving them feedback. And in many cases, if the parts are clear, we even print parts for them. We help them qualify with their end user, end customer, and then justify the process of investment and demonstrate why they should go for 3D printing vis-a-vis a conventional process. So this is how we approach them and tell them how to go about doing it.
And the process is very strict. There are a lot of what do you call, the certification they need, testing, and also do you help them in getting all those things?
Absolutely. Absolutely. Yeah. There's, I mean, only certain domain specific sectors ask for certification, but otherwise today still, even now, 70% of the printing that happens in India is all for prototyping. So for prototyping, you invariably don't need certification unless an end user asks you to do so. So from that perspective, you end up needing either an AS9100D for aviation sector, or a 13485 for a medical sector, or something else for specific sectors that are there. And even the standards are also only evolving now, specifically for aerospace. I mean, ASTM and ISO are only getting these standards right now for specific domains, and trying to see how they can support them in qualifying machines, processes, end components, etc.
Thanks, Dr. Vishwas. Dr. Kelvin, how does academia is solving this, problem? What sort of ecosystem, lab, or courses you offer to either students or to the industry at your
Uh,
facility?
yes, sir. Okay. In academic, actually, we are not actually working in the problem that the company, that the real aircraft manufacturers are working on.
Correct.
So there is a huge gap in this. So what academy has to do is we have to do a joint research project with the company, aerospace company, on a research projects, and which allows academic to work on real world problems while providing industries with access to cutting edge research and talents. And also our academy has to offer some internships. So sorry, the company has to offer some internship to the academic so that the students can gain some knowledge on the project or on the real world problems. So this is my insights.
Correct. Uh, Gaurav, how, how does Aerodef Nexus, solve this issue when you consult a client and, suggest them for additive, to use of additive, or, trying to give them a feel, or, to connect them with the right companies? How do you see, you helping the industry and, solving this problem?
Right. So basically, I'll give again a bird's eye view response to your question. Um, so basically, from a strategy point of view, you will provide, an overall plan for integration. So for example, we would work with our clients to help them develop a, additive manufacturing adoption roadmap. We'll advise them, to select which parts are to be manufactured with this technology, the prioritization of these parts that need to be manufactured, how to integrate these AM developed parts, how to integrate these into their supply chains, and advise them on the requisite training or process changes that are needed. So basically, when we have clients coming to us, often thinking that, additive manufacturing is just 3D printing, what we do is we advise them that, it's not just 3D printing. Like, the real value comes when you reimagine the part and the process as being AM induced. And it's not just the change in the production method. So, taking a bird's eye view, this is how I would, respond to your question.
Thanks, Gaurav. And before, starting this session, I was watching a lot of podcasts, and I won't name a company. A company in US have 1,200 machines, additive machines, and they are rolling day in, day out parts which are being used in, aerospace, their aircraft, whether it's airline, whether it's commercial aviation and drones. So people are using the technology, and India, we are also doing it. We have to adopt it fast. So, Dr. Vishwas, what are the major challenges to scale 3D printing with India's aerospace industry? I know it has a lot of benefits, but what are the challenges we see?
I think today the biggest challenge that we have is in the qualification process. Say now, for any part to be made airworthy, it's a very strenuous process of multiple qualification steps that have to go through for any part to be made or certified airworthy. So today there's one agency in India called Semilac who approves any space or aviation part as airworthy ready. So that's from the defense perspective. So it's a defense DRDO department who does this. And again, similarly from the aviation sector, there are others who do these qualifications. From what we understand, invariably it takes all the way up to about 5-6 years to qualify any part to be identified as suitable for flight. So that is the real long drawn process. And another important aspect that we have to see is India invariably has been an outsourced manufacturing company. I mean, from aerospace perspective, if you look at the bulk of aerospace manufacturing that's happening in India, I'd say 80 to 90% of it is to manufacture components for people outside India, be it Europe or US or other areas that we manufacture components. Now, additive manufacturing has invariably been a Western technology, a technology where equipment used to come from the West, powders used to come from the West, the process of manufacturing it used to come from the West, and the design or the customer also used to be from the West. So there's very less incentive that an Indian manufacturer had to say, we will manufacture it any better than what a Westerner can do. And unlike the conventional process, this is not a very labor intensive process, which will say, I can beat you in engineering and manpower cost. Okay, so this used to be this is the major challenge why we don't see the adoption of additive so much more higher as compared to the conventional manufacturing process in India. Whereas now what is changing is we have equipment available in India. We have Indian machine builders who are available. In all technologies, we have Indian machine builders available, be it polymers or metal. We have Indian material, raw material manufacturers. We have multiple manufacturers of powders or filaments or other material that is required for manufacturing in India. We have Indians with enough process knowledge. We have understanding of the entire manufacturing process, be it from a design to manufacturing or finishing these parts. Now we've come onto a place where we can debate telling how much more value we can add if they are made in India. So it's all a matter of time. We have a lot of customers, both, I mean, when I say we, I speak for the whole manufacturing industry, the OEMs. We've been working with a lot of end-use customers who have all been exploring India as a possibility. And like I said, it's a long-drawn process. It takes 5-6 years to even draw the attention of any manufacturers to say, yes, these produced on Indian machines can be as good, if not better, compared to the German or American machines. So that is in process now, work in process. So it is only a matter of time before this industry explodes into a large scale manufacturing hub in India. And we are very confident of that happening very soon.
And it's a great news to hear, Dr. Vishwas. Dr. Kelvin, what sort of challenges you see, in adoption of additive manufacturing?
The first challenge is scaling production. So adapting additive manufacturing, particularly for high volume production, while adapting additive manufacturing is a big task. Uh, the main problem here is maintaining the quality and cost effectiveness is a major challenge. As a result, it requires a lot of optimization in the machine outputs, material handling, and post processing. And the second main challenge is what I'm facing is integration with the existing infrastructure. So additive manufacturing with the existing infrastructure is difficult. Uh, so these are my insights.
Thanks, Dr. Kelvin. Gaurav, what are your thoughts on strategies for growth in this emerging sector? Since you are from a strategy side.
Yeah. Um, so, I would say that I think there's a lot that all ecosystem players in this field can do in order to support growth in additive manufacturing for aerospace. So in India, like, for example, government agencies and research institutions, together they need to invest in more R&D and innovation in this field. So basically, these stakeholders need to make funding available for, material development, part certification, and quality control. Next, the government and enterprises, together, they need to develop robust infrastructure, which would involve investing in advanced manufacturing facilities, testing and validation centers, and strengthening supply chains. Then in India, we do need to upscale our, existing workforce and talent. And especially in this domain of additive manufacturing, and this would involve providing comprehensive training programs and educational initiatives tailored to AM technologies. And this is something that we at Aerodef Nexus, this is something that we are already supporting and will continue to do so, especially in view of our composites and advanced materials training modules, which aim to bridge the skill gap. And I also feel that in order to accelerate growth in this sector, stakeholders need not reinvent the wheel by working in silos. So basically, what I mean by this is that we can all benefit by establishing a win-win partnership model by fostering and leveraging, an IP licensing marketplace system by virtue of which we can, dovetail off each other's advances in this technology and consequently generate revenue for everyone. So basically, it can be a win-win model, a win-win partnership for enhancing growth in this sector. And here also, Aerodef Nexus supports this ecosystem by establishing such a marketplace. And lastly, I would say that strengthening regulatory framework and incentivizing the adoption of additive manufacturing, this will play a very great role in promoting growth in the sector in India.
Thanks, Gaurav. Ladies and gentlemen, Laghu Udyog Bharati Karnataka is hosting India Manufacturing Show happening in BIC from 6th, 7th, and 8th of November, powered by Ministry of Defense, Ministry of Steel, Ministry of Heavy Industries. Do visit the trade show on 6th, 7th, 8th of November. Hall 1 and 2, there are a lot of live demos, a lot of conferences happening. We look forward to invite you for that show. And do drop your questions. We will take up the question. Dr. Vishwas, uh, I got a a chance to look at your first machine, and I can say I'm the first one because you told me you can see the machine, no pictures and all, because it was about to launch. I don't know how many years it was, and you have seen the machine. It's state of the art. From then till now, how do you see this industry evolve? And as an AMS also, what sort of new machines you have launched? What sort of clients you are dealing with? And can you let us know your journey from the first in make in India additive state of the art machine? I've seen that before the launch. After the launch, I've seen at your booth in Imtex, I guess. So can you let us know your journey, how MS has achieved that from
Right.
R&D and all?
So we've the machine got launched more than 4.5 years ago, and it's been. I mean, in fact, the machine was made about 5.5 years ago. We've been printing a lot of parts, qualifying the machine for various applications, because making a machine is one part, but getting the machine to print right and get the right parts, get end customers validate that and confirm that these are as good, if not better, than competition, is the most important aspect that we had in focus. So we've done that. Today we have a whole lot of customers who've onboarded the machines, and the machines are today, like I said, printing parts for ISRO. It's printing parts for DRDO. It's printing parts in many industries. In fact, some of them have come back for repeat orders for machines, so which just says that they're happy with the machine and performance. Today we're working extensively with both private sectors for specific applications in R&D and small batch productions, and also with some of them where there's continuous serial production also happening. So we've touched on the die mold industry, where machines are being used for making forging dies and punches, die casting components, inserts. We have plastic injection molds that are being made on our machines, large size ones, because we've largely focused on big components and heavy voluminous components that we've been doing. We work extensively with the healthcare industry to print parts for the healthcare components, equipment, and tools for healthcare that have come out well. In fact, if you see, the adoption rates also are much higher in AST, which is aviation, space, and defense, and the medical industry. They're the two large adopters globally also, and we are seeing that trend in India too. But the automotive industry is not far behind. They're quite closely catching up in terms of making sure their own die casting dies, their own prototypes, their small validation parts are all being 3D printed. So we've worked with more than 20, 25 automotive companies in producing parts for them and qualifying the technology for their specific applications. A lot of general engineering industries, be it valves, pumps, motors, and other such industries who adopted the technology and been printing parts for their applications. Again, as Dr. Kelvin mentioned, complexity is a key there, where you have a lot of challenges in putting parts together, where multiple parts had to be integrated and welded and then created as a single assembly. We can print it as a single shot in 3D printing, minimizing those secondary operations and the potential challenges that come by either rejections or leakages or other aspects in the process of usage of these parts, which have been overcome using 3D printing. So like this, we have right now connected with a whole lot of customers. And one of the biggest comforts that the customers get is we being an Indian company and someone being here for more than 40 years and with over 8,000 customers, they have this comfort level that these are people who'll stay and not someone who'll just show up as a blip in the technology curve or in the industry roadmap and then just disappear overnight. So that's what I mean. People will come and go, but the industry, the company is here to stay. So that's the comfort that manufacturers have been getting, which is what is one of our benefits having come to us.
And since your group is now a global group, you are participating in a lot of global trade shows. You are present in most of the countries. How do you see this when you travel? Because you travel to Formnext and other global shows. How do you see the the European market or American market taking Indian machine and Indian products?
See, globally, if you look at it, the biggest market has been US and Europe in a good time. I mean, when things have been good, barring the couple of years, 1 or 2 years of challenges and the immediate challenges that are being posed for trade, Europe and US have been the largest consumers, largely because the technologies were available there earlier and they were put to use earlier. So they have been the big consumers of this technology. Now, coming from India, there's a growing interest amongst manufacturers for adopting Indian products in all technologies. I wouldn't say 3D printing, conventional machines, CNC machines. Also, we've been having good working going on, and we've been associating with a lot of German companies, partnering with them to see how we can leverage on each other's strengths to make technology available to the European market. So we see this only going to grow. Of course, when it comes to a niche technology like additive, it's taken with a pinch of salt because India is not known so well to be a large additive manufacturer. But coming from a manufacturing background, the country is being taken seriously right now. It's not just for low-cost manufacturing, but high production and high productivity manufacturing also is being considered as a forte for India and Indian OEMs.
Make in India, made for the world. Thank you, Dr. Vishwas. Dr. Kelvin, how do you see additive manufacturing? Does it have any application in the tooling industry?
Uh, yes, sir. Additive manufacturing has a significant amount of application in tooling industries, particularly in injection molding applications. Uh, let's understand how injection molding works first. So all the plastic components are made by injection molding techniques only. So the plastic granules get heated to the liquid plastic state and then injected into the mold, and the liquid plastic material takes the shape of the mold, and this liquid plastics slowly cool down till the desired shape is attained. After that, the plastic will be removed. So this is the working process of injection molding technique. So during this working process, what happens is this mold will get warm after a few cycles. After 5-10 cycles, this mold get very hot. So to reduce the hot, so what happens if the mold is getting very hot, it will not allow the plastic material to cool down effectively. So generally, they will have a cooling jacket. They will circulate a water, and it will release the heat from the mold. So there is a concept called conformal cooling channel, which means the cooling channel will closely follow the shape of the mold, which closely follow the shape of the mold, and it effectively release the heat from the mold. As a result, the productivity will increase. So this conformal cooling channel is in complex shape, which can be 3D printed by direct energy deposition method. In this way, the 3D printer will support a tooling application.
Dr. Kelvin. Gaurav, I see, Dr. Vishwas also spoke, Dr. Kelvin also spoke about skill and, the manpower. And since I have seen a lot of your, posts and all where Aerodef Nexus is focusing on, apart from your consulting and on different other, because you are into a number of verticals, which I see. How and but one vertical is, is my interest where you are trying to, solve the skill gap where you are trying have a education side also. So can you let our audience know more about what you are doing in that space? What sort of courses are available? And because I see you have got a big expert panel, you are bringing industry leaders, solve that. Can you let our audience know more about that division of yours?
Yes, yes. So a key vertical at Aerodef Nexus is our vertical associated with training and knowledge services. So, and to give a bit of context to our audience members here, you know, India produces, as we all know, a large supply of engineers who graduate from colleges, from the universities. But when they go about, searching for jobs, or when, employers out there, they want to hire them, from our research, from our analysis, we found that there's an immense skills gap within this sector. And additive manufacturing is no different. From what we've seen is that employers desire, they value graduates who are very proficient in the nuances associated with this sector. For example, having familiarity with AM design processes, with AM materials, and all that. Now, to bridge that gap, again, this is, we are a for-profit company. This is a business. But at the same time, what we're trying to do is provide knowledge offerings that can bring immense value, immense benefit to graduates, bridge their skills gap, and also, bring immense value to employers out there looking for graduates who are knowledgeable and familiar in this area, so that they don't have to, start from scratch, training and building skills within these engineers. So, for example, one of the courses that we have launched in this direction, it involves composites. So it's a comprehensive training module that provides students with a 360-degree viewpoint of the use of composites in general within and especially in context of the additive manufacturing sector. So basically, all the whatever it is that students need to know in order to excel in this sector, make their credentials stand out to be and so that they're immediately desirable by employers. These are the kind of skills and trainings that we are providing here at Aerodef Nexus. So again, as I mentioned, this is a key vertical, and the way it's been formulated is to provide this kind of a win-win type of model to all stakeholders in this sector.
Thanks, Gaurav. Dr. Viswas, we have spoken about aerospace. During the Russia-Ukraine war, we see a lot of drones are being used, and I was looking at a video where, since it's a UAV, people have a big setup where additive manufacturing machines are there. They are printing parts, and the drones are ready to go. How do you see the use of additive, especially in drone companies? Do we have any case studies? Are you working with any drone companies? Because I see there the norms are little, I think, in terms of design and all, are little non-strict. I can be wrong, but how do you see the use of AM in that drone segment?
Absolutely. See, today drones definitely are a very, very popular use case for additive because you're able to make parts lighter using additive and you're able to make print assemblies. So now in drones, like you rightly said, they're not super critical unless they're a very large payload carrying drone that's there. which is very rarely used, but bulk of them are used for reconnaissance, surveillance, and such applications. And today, I mean, non-defense related applications also are growing immensely, tremendously today in India for drones. So considering the defense application today, I mean, the topic that we're discussing today, the advantage that Additive gives you is you can print some very strong materials and very light ones. So that can be printed using some polymer technologies. And they can be produced in a very short time, and they can produce continuously 24/7. They can be printed and then brought out into the market, and they'll need, with minimum intervention, with minimum additions, they can be ready in a very short time to be deployed for the end use purpose. So today that is a big application. Today you have them not only serving the defense segment, but you also have them serving to the other commercial, farming, and many other newer segments also. So going ahead, this will be the order of the day. We will have a lot of autonomous air vehicles, autonomous ground vehicles, water vehicles, maybe combined vehicles, and all of them. Considering the varieties, it doesn't make sense to go with the conventional method to produce them, because you don't know how much the volumes will increase with market. So 3D printing may be the most suited application for them that are there. I mean, today, for asking about the possible use cases, from what we know, a lot of these drones are 3D printed using polymer materials. Since we've largely been in metal, we know one of our customers did use one of their drones where a small camera-based part was produced by us that was used in the Operation Sindoor, which we produced the few samples of those drone camera assembly, and that was taken up for that operation in a very short time, and that was deployed, and they got very positive feedback from it. So like this, there are many, but invariably customers are hesitant in sharing a lot of their end use applications, because they're all signed under NDAs, and they can't be revealing the end applications. But definitely there are people using the technology extensively, but they just don't get the visibility that is required for what they're doing. But yeah, India has matured significantly in these years to adopt some of these advanced technologies for some good applications.
Thanks, Dr. Vishwas. Future is UAVs, and additive can play a very important role, because the way we have seen in Operation Sindoor, and the way we are seeing in Russia and Ukraine, where people don't want, it's like fifth generation warfare, where they don't want to send their actual planes, where if they go down, the losses are less, and again in some time they can print more parts in the UAV is ready. Dr. Kelvin, how do you see the use of additive in drone technology and drones?
Yes, sir. In drone and defense sector, most of the most of them are made by plastic materials, not a metal one. So, okay, so plastics can be classified into three groups. One is basic plastics, and the second one is engineering grade plastic, and the third one is high performance plastic. In defense sectors and in aerospace, high performance plastics are generally used. For example, PEEK, which is called as polyether ether ketone. The strength of the PEEK is as strong as the steel in terms of volume. Okay, but the weight is just 1/5 of the steel, so it has high strength, exceptional strength to weight ratio it has. So generally this type of PEK materials are injection molded parts, injection molded parts. But in recent days we are it is available as a filament, so we can use 3D printing technology like FDM technology to print it, and it can be used in a real world application as well. And one more important properties of the PEK is it has it can survive at very high temperature, up to 260 degrees Celsius. The plastic material can withstand. So this is the plastic material which can survive at the highest temperature. Up to 260 degrees Celsius, the material can withstand without getting any damage or loss of its property. So there are another material like CFRP, carbon fiber reinforced polymer. So it is also be manufactured by FDM technology, and also by there is one more technology called automated fiber placement machine. So in automated fiber placement machine, it's more like a FDM technology. It precisely deposits the fiber impregnated with resins on a mold, and the head has a special setup that apply a pressure and heat so that the fibers are tightly intact. So whereas in FDM, a filament is heated to the glass transition temperature and deposits on the build platform layer by layer. Whereas in automated fiber placement method, it is more like FDM, but it has additional setup that apply compression force and temperature to ensure that the fibers are tightly intact. Uh, yes, so these are the things which we can explore in defense sector. And there is one more thing called foam metal foam.
Okay.
So which is
Okay.
it comes under advanced high weight or advanced lightweight application, which is known for advanced lightweight application. The material will have a large volume fractions of pores and voids. So one of the main application of this foam metal is it is used as a flame arrestor, it is used as a thermal barrier support and blast mitigation and efficient heat exchangers. This type of foam metals are used in spacecraft, particularly when the spacecraft is entering into the atmosphere. A lot of frictional heat will be generated. That frictional heat should not be transmitted to the cabin crew. It should be effectively eliminated. It should be effectively transmitted to the surrounding environment. In that application, this metal foams are used. But the challenge here is there is no direct 3D printing technology to manufacture this metal foam as of now. They are using the 3D printing technology like direct energy deposition and powder bed fusion technology, but there is no direct metal foam 3D printing technology. So, what is the drawback in direct energy deposition and the laser powder bed fusion technique in order to manufacture the foam metal is removing the support is very difficult. This is very challenging. So that's why we are looking for some R&D kind of thing to develop a direct metal foam printing. So that uses sacrificial support, which can be easily removable. Yes, sir.
Yes, thanks, Dr. Kelvin. I'm enjoying because I'm learning so much from you. The detailed one. Gaurav,
Thank you.
you it's not related to additive. So how do you see the overall enthusiasm of when you meet a Indian SME, MSME or large aerospace companies? Uh, and how do you see the market growing, especially in aerospace and defense? Because I've seen you were meeting series of companies. Can you let us know how do you see the feel of Indian companies? And I will not talk about US tariffs now, but how do you see the overall? You are mute, Gaurav.
Sorry, I was talking to myself. Uh, yeah, you know, we are seeing so much demand, immeasurable demand from, a spectrum of clients who are interested in, exploring and developing solutions in this area of additive manufacturing. We have demand coming in left and right. Um, and I think a lot has to do with the prevailing ecosystem um, associated with additive manufacturing in India. And to an extent, I think my response kind of also may address this question that we have in the chat window there. That nowadays, in India, we are using 3D printing a lot for prototypes, and the cost is very high. How do you think that we can use metal 3D printing for mass manufacturing? Is there any plan to reduce the cost? So I mean, if I had a crystal ball and if I would and based on that, if I would gaze into the future, then I would say that the day is not far when we here in India we could use 3D printing for mass manufacturing. And as I was saying, that a lot has to do with the prevailing market dynamics associated with additive manufacturing in India. So basically, this sector is gaining a lot of traction, especially in context of the aerospace sector. And based on our analysis, the Indian metal additive manufacturing market is projected to nearly double from $254 million to almost $500 million by 2030, reflecting a very strong growth rate. And this is, in fact, the fastest growing in the Asia Pacific segment. And the aerospace and defense sector, it already commands a substantial 33% revenue share when it comes to India's metal additive manufacturing market. So it does not come as a surprise that we are seeing immense demand and immense interest amongst a spectrum of clients who want to invest and grow in this sector. So and in general, like, a good example that, the future seems bright is that already India is making a lot of progress in this field. For example, there's this Indian space startup, Agnikul Cosmos, which developed the world's largest single-piece 3D printed rocket engine from Inconel, which is an advanced material. And this showcases that India has capabilities in cutting-edge aerospace, additive manufacturing. And besides this, we're also seeing strong support from the government here. So basically, like, some supportive policies of the government, such as the national strategy for additive manufacturing. This targets achieving at least a 5% share of the global additive market by 2026. And it highlights the strategic importance placed on this technology. So overall, I would see, like, the future to be very bright. Again, we are seeing a lot of demand, a lot of interest, and this is only projected to increase down the line.
Thanks, Gaurav. Dr. Vishwas, I have heard, or people talk about dark factories in subtractive in China and all. There are big dark factories. A, can we see dark factories in India for additive? B, a two-part question for in the dark factory, and the second one is we have design as a service. Sorry, software as a service, where all those top software companies to cater MSME and SME, they have come as a monthly sort of subscription model, where they can, small companies can use or startup can use those services. Same thing, design as a service. A lot of companies are there. So because when a company thinks about additive, they think it must be a very expensive technology. Will I get my prototype? What will be the cost and all? Because people are hesitant. I meet a lot of customers, like, they're happy with software as a service, design as a service. In future, do we see additive as a service, where they can walk into your office and sometime he can get a a prototype, or something which startup can come and get a design and everything done, and then they can go to the startup pitching or something, or they can show to their investor or show to their companies. Two-part question. One is the dark factory, and the second one is this additive as a service.
Sure. So dark factory is definitely possible, but it's a little long short for India. As you're aware, India is a very risk-averse country. Additive is still at a very nascent stage in India. Globally itself, from an adoption perspective, it's an early stage right now. So it is going to take a lot of time before additive becomes mainstream, at least for some of the mid-sized, component manufacturing industries. I would say industry meaning the non-automotive is what I'd like to focus on. So today, the dark factories in the world where you'd see probably something happening like that are all industries where your volumes are still suitable to produce them in that kind of numbers, and which is possible. In fact, we ourselves are talking to at least 3 or 4 customers where the part production cost per component is equal to the conventional one, which they have found out. It's now they're looking at how that can be automated, how they can leverage on some of the other costs. So in many ways, we've come to closer to what can become that. But to be able to run them continuously, automatedly, will need a lot more discipline, a lot more opportunity in the market itself to happen. But I wouldn't say it's not possible. It is very much possible. But in my opinion, even if it happens, it'll happen in a small scale right now, and in the next 4 or 5 years, it might happen in a larger scale because of the volumes to be able to pick up in India. So India has always been a little careful country in terms of investing, and this would call for upwards of many tens of crores, if not more, to be able to even think of something like that, because it will need a lot of automation. And when someone who does that kind of investment, if they don't have a business case suitable to get that returns on it, it's going to be very difficult to justify. And many companies have also gotten into trouble for having gone investing very fast, very soon, without knowing how they can put such things into use. So those are some of the challenges that are there in ensuring that we get the do that. And it's not, like I said, in other countries, it's happening. Only in China, we are seeing this happen. Even in 3D printing, there are dark factories where people have lights off factories. And there they have one advantage, which is they have huge capital that is being infused by the government. and by the state, especially the state government, in terms of funding them to get into this technology. So it has become a matter of high importance in China because they've realized the technology is important and the technology has potential. So there is a lot of funding that is being given both to OEMs, to manufacturers, and the end users to be able to leverage on this technology. So those are some of those specific strategies which can accelerate this process of better adoption in the whole process to achieve the dark factory kind of a thing. Coming to your
Second question.
second question, I think you were trying to ask about
Additive as a service where people
so
can come.
right, additive as a service. My bad. Yeah. So the second, so that is definitely happening today as we speak. There are about 60, 70 metal printers and about 200, 300 plus polymer printers, which are all being used as for services where parts are being produced as a service by service bureaus who are doing this. Now, in the process of converting that in terms of how you do it per hour basis or per, in fact, all the polymer parts today, most of the polymer parts are being quoted by gram basis. I mean, you give them a 3D model based on the volume or the gram, you yourself can calculate how much it will cost. So that's how the polymer industry has been working. Metal works a little different. So it's only a matter of time before multiple of the users come up with methods to incentivize end users and then qualify them to become more suitable for this kind of a model. But this industry, the service segment, is likely to grow at a faster rate than the OEM end use industry itself. That's what is being predicted, but largely because there are more and more people who want to use additive, but fewer ones who want to invest in the machine themselves. So they'll largely settle for getting the services done from service bureaus in the country so that they're a little less risk or capital intensive, so they can go with the OPEX model where they can leverage. And today we have customers who've been telling that, look, if there are machines available, we would like to book about 1 week's of business every month, 10 days of business every month on these machines so that they can share the load, they can share the investment to that extent. So like this, a lot of collaborative approach is also happening. And very soon we will have additive as a service or print as a service coming up where things will be put up online. And there are a few who've started doing that too, where you can upload your 3D models online and then automatically generate the codes based on some engine which runs and then gives you that costing. And then it can be pushed directly to an order and then parts can be taken up for production. So many of these have been happening in a very small scale, but it's with the time, I'm sure this will scale up to become mainstream too.
He said it's a classroom session. But I'm loving it. Dr. Kelvin, I know we are in the last 10 minutes and I want to utilize because for me, it's apart from, people who are listening to it, for me, it's getting to understand about the technology, to understand so that if as a media, we also write the right set of content so that, people can read and all. So, Dr. Kelvin, what sort of, since IISc is into a lot of things, what sort of, do we have any AM center with you, or what
Yes,
sort of
sir.
courses you are offering, more about your offering, what you do, and how industry can reach out to you or students can reach out to you if they wanted to learn about this technology, about your machine, or visit, your centers.
Yes, sir. Okay. So actually, sir, actually we have 4 kinds of 3D printers in my lab. So there are 3 types of 3D printer which is related to polymer based 3D printer. We are providing as a service. We are providing additive manufacturing as a service.
Oh,
So the 3D printers are, one is FDM technology, which is very common, and the second one is masked stereolithography, which uses photopolymerisms. So basically, and the third one is MJP printer, multi-jet printing process. So this MJP printer is the advanced polymer 3D printer. It has tiny jets that deposits photopolymers on the build platform and which subsequently get cured by the UV light. Accuracy of this MJP is very high compared to MJP and MSLA. So the accuracy we can expect around 30 to 50 micron. So it depends upon the part size. If the part size is less than 1 inch, which is 25 centimeter, or 2.5, sorry, 25 mm, if the part size is less than 25 mm, we can expect the accuracy between less than 30 micron. Whereas if the part size is more than 1 inch, the accuracy may varies from 50 to 80 micron. So this kind of missions we have, and one more missions we have is a direct energy deposition mission. So this missions primarily, so a lot of research work is going on in direct energy deposition mission. The one such researching is developing a functionally graded material. So this particular 3D printer has a capability to build two different chemical composition, which means two different metals to create a single parts, so that the material has a two different mechanical property. We can create a top surface very hard and solid for better abrasion and wear resistance. The bottom layer can more tough. So like that, there are multiple combinations we can do. We can play around with the functionally graded material, and also single crystal alloy. Uh, mm, for example, the single crystal alloy has a better creep resistance property. Creep is something like a permanent deformation which happen at high temperature under constant load. This type of creep deformation, resistance to creep deformation, is very crucial for aerospace applications. So those type of developing a single crystal alloy using direct energy deposition is going on. So right now in our labs. So these are the things we are, and also we are offering some courses in our DCOE program. So the courses are related to Industry 4.0 and design thinking, design prototyping, mechanical prototyping, electronic prototyping, ergonomics and human factors, and business development module. So there are totally 8 courses are there. Each modules are 1 week program. So we are giving it, it's basically it's a full of hands-on session. So right from Industry 4.0, it's full of hands-on section. We will train what is Industry 4.0 and what are the benefits, how industries are getting revolutionized based on the AI based thing. So all these things we will train in 1 week module. Similar way, there is a design prototyping, mechanical prototyping. Everything is a hands-on training for a 1 week modules. We have this 8 course we are offering, sir. Yes, sir. That's
And
all from my end.
okay, one what do you call? I wanted to ask more that do they come to you, or your team can go to companies, for example, let's
Yes,
say
sir.
there is a
Actually, since it is a
okay,
in training purpose perspective, students has to come to our college and enroll the program. There is a website
okay,
called DCOE website. You can check
okay,
in the internet. Design
okay,
Center of Excellence, DCOE. In that you
DCOE,
can register for the course. You can
okay,
clearly see the course details, everything in that website. And there is a event. We will go to different colleges and we will conduct an event. That is a 1 day event. So we will
okay,
give a brief overview of all the modules, all the 8 modules. We will just give the glimpse of all the modules. There is no much hands-on session because in a 1 day we cannot cover all the 8 modules.
correct,
So we
correct,
will just give a glimpse about our program, right? In
correct.
terms of additive manufacturing as a service, uh, you can reach me through my mobile number, or you can mail me. There is an email ID which I will share it to you, sir. So through that, the people can reach me, and we can provide additive manufacturing as a service.
Thank you. And looking forward to visit your facility very soon because
Sure, sir.
your IISc is very near to
Welcome.
us, where I am, where me and Dr. Vishwas is sitting. It's very near to us.
Congratulations, sir. Yes, sir.
And so we are on the last 5 minutes. Dr. Vishwas, industry academia, like Dr. Kelvin, pushed. He said talked about industry academia should work together. So how do you see this happening? How are you, solving this problem? Uh, are you doing projects with colleges, or are you offering any internship to them? And how are you addressing this? The skill gap, we can say industry academia collaboration, work on projects.
Oh yeah, absolutely. We've been working extensively with the academia. In fact, even before we started this company, we've worked with the IITs and others to get projects rolling. So we've been fortunate to have multiple grants received from the government for incubation of different technologies. We've worked extensively with IIT Bombay, IIT Guwahati, and in fact, even with IISc, we've worked with the professors to get some of the projects going in some of the optimization. We've worked both in India and outside. And today we've also been doing work with some of the other premium institutions in the country where not only internships and training programs that we offer for university students and some of the faculty members, but we also run some of the projects together in terms of doing some analysis or doing some testing of at a coupon level or at an application level. So we strongly believe there has to be a good collaboration where industry can rely on academia and academia can support industry for us to grow and support and get the right application out and get the right solution out to the end use market. So we can't be working in silos. Today, we've seen this work very well in the West. And today, even in China, Taiwan, and many other Asian countries, we've seen the strong influence of academia into development. And we believe it will have good results going ahead. So there is a strong need for collaborative working with multiple agencies to get good results out of it.
So the last question, which can be addressed by everyone, because we are in the I won't take questions. Is there any question? Okay, one question I will take. This is from Shruti Shukla. As aerospace innovation accelerates with additive manufacturing and advanced material, how can consulting partners like us, okay, they are into consulting, collaborate with industry leaders to strengthen cyber security and enhance design to delivery workflows? Dr. Vishwas, Gaurav?
Okay, I can take a stab at that first. So I think consulting partners, if they want to collaborate with industry leaders to strengthen, various domains associated in this sector to enhance design to delivery workflows. From my viewpoint, I think the most seamless way to do that would be to take advantage of prevailing licenses, IPs, and other such material developed by firms in this sector already. There are marketplaces established to do that. We at Aerospace, at Aerodef Nexus, we have also established such a marketplace wherein, stakeholders or partners who want to grow and expand in this sector, they can take advantage of IPs and licenses in this marketplace and, grow based upon leveraging the same. So, from my viewpoint, that will be a seamless way of achieving that.
Dr. Vishwas, you want to add anything?
No, I think that's fine. That he's rightly answered. I think it's in the right direction. Yeah.
Okay. So last question to each one of you. I know I have 3 minutes. Why companies should choose additive? Why additive? Whether it's any stream. I will start with you, Gaurav. Why additive?
Why additive? I would say, why not additive? It offers cost efficiency. It reduces wastage. It can be used as a, from a macroeconomic point of view, it can, additive manufacturing can be the next step in the whole industrial revolution process or era, as you want to call it. I think it can transform the way, components, machines are designed and manufactured. With enhanced cost efficiency, reduced wastage, companies can see immense turnaround in their overall, profit margins, enhanced revenue streams, and so forth. So I would say, additive manufacturing is the way to go.
Dr. Vishwas, why additive?
See, additive is not just a fancy word which people are trying to, they would want to use to make their resume look good or just to brag about it on their website telling that we are doing this. It should add value. It should solve problems. If it can't, then it's not the right technology yet. So there's no point in switching to additive unless there's really some value addition. There is some solution it can drive. So which is why, you'll be surprised there are many large OEMs worth many billions of dollars today. They've not even started learning the spelling of additive. So it's okay. That's no problem. It's fine for them. Their manufacturing industry works the way it is. They've not found the need to adopt to additive. Today, the dynamics in the industry is changing. The consumer behavior is changing. People want fast, everything to be changing fast. People want results fast. People want solutions fast. So in that environment, one of the technology, I wouldn't say the only technology, one of the technology that is solving, that is stepping up to provide solutions is additive. So additive will become a science, a tool, a methodology, a medium to get to being better and faster and much more useful to an end user. So that's why additive.
Thanks, Dr. Vishwas. Dr. Kelvin, why additive?
Sir, in my perspective, additive manufacturing gives freedom to the designers. So designer has to focus only on the functionality of a product, not on the manufacturability of a product. So in conventional manufacturing method, designer has to focus on the manufacturability, whereas in additive manufacturing, designer has to focus only on the functionality of a product. So I will strongly recommend that additive manufacturing will give uh, is the best choice for aerospace and defense applications, and also in medical applications as well. So there are a lot of things to explore in additive manufacturing yet. So there are a lot of interesting things are going around in additive manufacturing field. So yes, sir, additive manufacturing will be the future.
Thank you. Thank you to all the esteemed panelists. Thank you, Dr. Vishwas. You have always been kind to me whenever I ask whether it's artwork, whether it's your article, whether a one-to-one meeting. You have always helped me. Thank you, Gaurav.
Thank
Looking
you.
forward to meet you soon at Aerodef Nexus office. Someday, I will, meet you very soon. Dr. Kelvin, looking forward to meet you at your facility very soon. Thank you, ladies and gentlemen. If you have any questions, do send it to me. I will share it to the respective speakers. Thank you, Dr. Viswas. Thank you, Dr. Gaurav. Thank you, Dr. Kelvin. Thank you.
Thank
Thank
you.
you.
Thank you. Thank you so much.
Thank you.